Hello and welcome! Today we're diving into the fascinating world of nuclear energy, specifically how a nuclear fission reactor works. From splitting atoms to lighting up cities, we'll break down this process step by step so that anyone, from students to curious minds, can understand it. Let's get started! Imagine an atom, tiny, invisible to the eye, but packed with massive energy. Nuclear fission is the process of splitting an atom's nucleus, usually uranium-235 or plutonium-239. When a neutron strikes a uranium atom, it splits into two smaller atoms, releases more neutrons, and releases a huge amount of heat energy. These released neutrons can then strike other uranium atoms, causing a chain reaction. This chain reaction is what powers nuclear reactors. Fun fact, Einstein's equation, E equals mc squared, explains why so much energy is released. A small loss of mass during fission gets converted into... Let's now understand the main parts of a nuclear reactor. Fuel rods contain enriched uranium pellets. This is where fission happens. Control rods, made of materials like boron or cadmium. They absorb neutrons to control the chain reaction. Insert them to slow down the reaction, withdraw to speed it up. Moderator, slows down neutrons so they can trigger more fission. In most reactors, water acts as a moderator. Coolant, carries away the heat from the core. Again, water is commonly used, though liquid metal or gas can be used in advanced reactors. Pressure vessel, a steel container that houses the reactor core and coolant. Steam generator, uses the heat from the coolant to turn water into steam. Turbine and generator, the steam turns the turbine, which spins a generator, producing electricity. Containment building, a reinforced structure that houses the reactor and protects the environment in case of an accident. Let's walk through how it all works together. Initiating the reaction. A neutron hits a uranium-235 nucleus. It splits into two smaller atoms and releases energy into more neutrons. Chain reaction. The released neutrons strike other uranium atoms, continuing the reaction. Controlling the chain. Control rods are adjusted to maintain a stable, steady reaction. No runaway explosions like a bomb. Heat generation. The fission reactions produce immense heat, which is absorbed by the coolant. Steam production. This hot coolant goes to the steam generator, where it heats water into high pressure. Electricity generation. The steam spins a turbine. The turbine spins a generator, producing electricity. Cooling and recycling. After the steam passes through the turbine, it's cooled back into water by a condenser, and the cycle repeats. Safety is key in nuclear power. Multiple layers of protection exist. Reactor shutdown systems. Drop all control rods instantly in emergencies. Containment building prevents radiation leaks. Redundant cooling systems keep the reactor core cool even if one system fails. Radiation shielding. Thick layers of concrete and steel prevent radiation escape. Post-Fukushima and Chernobyl, modern reactors are much safer with passive safety systems that function even without human intervention. It's appreciation that we just need first 20 seconds. SMOC PASH advantages. It produces a massive amount of electricity. No greenhouse gas emissions during operation. Reliable, can run 24/7, unlike solar or wind. Very efficient. 1 pellet of uranium equals 1 ton of coal. Disadvantages. Nuclear waste is radioactive and must be stored safely. High initial construction costs. Risk of accidents, though rare. Public perception and political issues. Exciting advancements are being made. Small modular reactors, SMRs, safer, cheaper, and more flexible. Thorium reactors, less waste, lower risk. Fast breeder reactors, use nuclear waste as fuel. Integration with renewables to create clean hybrid systems. Though fusion may be the ultimate future, fission is still crucial for today's energy needs and climate goals. And there you have it, a full look at how a nuclear fission reactor works. From atomic splits to electric grids, nuclear energy is a powerful tool. Like any tool, it needs to be handled with care, respect, and responsibility. Thanks for listening. If you found this helpful, feel free to share, subscribe, or explore more science topics with us. Until next time, stay curious.